Good morning.
Hi, good morning.
Hello.
Good morning.
Morning, Andrew.
Yeah, we will discuss about the last one because currently, SIU rejected our proposal, rejected to move the fastener to final assembly. But these two boxes belong to top head, so we need a way to discuss with the China PD top head team.
What's this one? You got a picture of it or show it?
Check.
On the body side, isn't it? Oh, no.
Yeah, body side here we have two bolts. Previous should be fixed in body shop, but we have ergo issue with two lower on the body shop. So we plan to move these two bolts, totally four bolts, two side to final assembly, but they rejected due to the GMR.
What vehicle is this on? Which model?
The CD542.
CD4.
Yeah, for we our other C2 program we have this boat also, and this boat is installed in the final assembly. So we want to transfer.
Oh, okay. Sorry. So another C2 platform's final assembly do it? You're saying?
Yes, C519, C430, we already aligned. Transfer this boat to final assembly.
Okay, we need to push that in very, very hard if that's the case. Yeah.
Yeah.
Yeah, but for the CD542 final assembly team argue that they have a GMR. If we transfer to final assembly, we will against the GMR. So
What's their GMR? What's the GMR for?
GMR. Bella, can you open the document I sent to you last week?
Yes, I have a copy of GMR. Just a moment. GMR 138.
What is it?
Yes,
Must be covered running 3-point system without additional issues. Okay. Protection drainage needs to be verified. Cross car shop.
Yes, final assembly team will discuss with the GMR order. The order confirmed that this boat should be installed in body shop.
yeah. The GMR creator clarified that this is a body standard part.
I'm sorry, I was unable to discuss with you. Really a new subject from my personal perspective for these two. When production for Ford FMA was cancelled, I was reassigned to other programs. The issue is fully within PNC upscope, and I'm instructed to stay within PNC parameters. Relative to GMR, these fasteners should be part of structure as it goes through E-coat and paint. Should be. Yep.
Yeah, nobody should be.
Well, what's it saying? So, if GMR says these fasteners, wouldn't use those words, would it? Well, what's it mean by these fasteners? What's the definition of these fasteners? These are located in an area of significant corrosion potential, yeah? But it is unclear what the strategic function is here. The reason for the cost savings is also not really apparent. Yeah. Also, with this being a C2 platform, it should follow the main platform lead. Yeah. As a sign deviation be required to approve this change from the GMR. The C2 versions prior to this may have that existing deviation to leverage or expand into CD 542. If it does indeed carry over from C519, line sign stop. This should be agreed to within the Chief Alignment Forum meetings for BCE, what's P? Paint Engineering?
Yes.
And Final Assembly to consider impact. And Regional BME Director sign-off is required for deviations. Okay, so what do CAF want to do? CAF want to do it in Final Assembly, do you know?
Yeah, in final assembly is the best choice. Even in body shop, we will have argo issue.
Sorry, say it again.
I mean, install this bolt in the final assembly is the best choice. If the bolt installed in the body shop, we will have argo issue.
Yes, I understand that, but what does CAF want to do? Do we know? Would they prefer to do it in body or final assembly if we ask them if they were making the decision?
We should have the same point. I think they want to install in final assembly.
Do we know that, or we just think that? Yeah, I'm asking what CAF, not what body wants. What does CAF? What would CAF management want if they had to make a decision? TCF or body? Not their body shop management. What would their maybe their paint manager or someone what would be the best for them?
I can confirm with the CAF AE team. CAF AE team what they want.
All right. So who is David Lasky? Who's he work for?
Sorry, Andrew.
David, the person who wrote this email, who does he work for? He's North America?
Yes, I think so. The David, I think so, in North America.
Final assembly. So he's BOMI, yeah?
Yeah. He is from final assembly, not from body.
Okay, but BOMI, yeah? Correct?
Mm-hmm. So he's the creator for this GMR. So his understanding is it's the standard part of body shop. That's the
okay. So he, okay. So you went to him for advice on the GMR. Okay. Okay. Paul Greenbank's on here, yeah? Okay. Can you guys send me this email, please?
Yeah, sure.
And what I need is the background information showing which vehicles already have this bolt confirmation, the same bolt on the platform. Yeah.
Okay. So, and we have the basic information. So I'd like to give you more information. And like this PPT, how many the model used in final assembly, and give you the picture or flow chart. That will clear how many vehicles currently we have 1, 2, 3 models fixed in final assembly. But it's not the same plant. Only, sorry, Paul. How about these 3 models fixed in which plant? CAF 2, CAF 3?
That's CAF
3.
CAF 3, CAF 3, CAF 2.
Okay, CAF 3, CAF 3, both used only CAF 1, because 542 in CAF 1 final assembly reject. Okay.
So what we're saying is CAF 2 and 3 have the bolt in final assembly, correct?
Yes.
Yes, and this is the assumption. Yeah, this is the assumption.
Assumption, so it's not actually happened yet. I thought I saw you referred to 519. Where's 519? Does 519 have this bolt?
519, yeah, 519. They have this bolt. We install in the final assembly.
So C519 and
Okay, so that's in production now, yeah?
Yes, in TT builder.
so Paul, this information correct?
Yes.
Now, let me, is it identical? Is it similar? How close is the design for that 519?
It's similar position and similar process.
Okay. So maybe give me that back up too, okay? I'll push up through Andrew Sahili, and if he not move on it, then I'll push up to Andre. But it may be. Is there any reason from final assembly? Is Paul Greenbank given any reason why they wouldn't do this process?
Just against the DMR. And
Okay.
also for the cost, if we transfer this process to final assembly, they need some cost for the DC nut runner for tooling.
Okay. And what do we need in body if we do it in body? What's the impact in CAF1 if we do it in body?
If we do in body, we also need some cost for the tooling, and then also for the ergo issue will be a problem because the boat position is very low in the car. The operator, it's very hard to install the boat.
So do we think it's required for any structural reason through paint shop? No?
If we install in the final assembly, the boat will be coated, and then so no need to go through the paint shop.
Okay, so it's more about corrosion. This vehicle will go to North America though, yeah? Will this vehicle be exported to North America?
And you mean C519?
Well, both 519 and 542.
542, you will import to Europe. 519, yeah, 519 will export to North America.
Yeah.
Okay. Who has more strict corrosion, Europe or North America? Probably North America. Well, it sounds like 519 already has, well, problem this is if I raise it, it may come back and we have to do 519 as well if we lose the argument. Yeah. Okay, does anyone from Shane's team, Shane Roberts' team, know what the history of 519 is? Did we get a deviation?
I'm not sure. I can confirm with the C519 team they got a deviation or not, but I will confirm.
Because they may not with a corrosion issue. Okay, so if they haven't got a deviation, then PD may just say, no, you've got to do that one as well, because you're going to export to US, to North America. This could come, we could end up worse out of this, but we've got to give it a try, I think. Okay. If you guys get me some of that information, please, and send it to me.
Okay.
Okay.
And I'll see if I can push, see what happens.
Okay. Okay, so Paul, this data is okay for you to provide some material, then you can send to Belgium. That's okay. And next, as we know, I got the information from Maggie confirmed that C430 will be moved to Cap 3. So all the open and closed items we have to go through again.
Yeah. Andrew, as C430 moved to Cap 3, so for the serial and the fastener community, we will restart about that. And currently we have one open issue is because in FAA, the C430 will be the same plant with CD391. So that means for the serial and the fastener, in FAA, they will try to comment with CD391. But for AP, our strategy is common with C482. So that means they will. So that means our strategy is different. So sometimes, for some design, we should maybe we need require the unique design for AP. But for FAA, earlier I discussed with them. They don't agree with that.
So complexity will come because we're now sourcing to a different plant across product lines. Okay. Who in North America not agree?
The LMEA. The LMEA in FAA.
LMEA or LVA? LMEA or LVA? LMEA.
Both. LMEA and LVEA are North America. Both.
Yes.
Okay. We need to work through the LMEA, correct? So they're meant to be doing the work for us, yeah?
For the unique design, we will do by ourselves.
Sorry?
So we can ask them to help us to push PD.
Yeah. So who's the person that can push from LMEA? You know?
After meeting, I can send you the CDI study of the LMEA manager here.
But no, I want to see who in the LMEA you've asked to help. You said LMEA not agree. If LMEA not agree, then which manager have you spoken to in LMEA?
The manager here, you mean?
Yeah, you said, well, unless you made a mistake in what you said, right? But if you've spoken to the LMEA, was it engineer or manager?
He's the supervisor.
It was who? Sorry? PD supervisor or LMEA?
The BCE supervisor for C430.
LMEA supervisor.
Who was the LMEA person you spoke to?
Eric Barr. He reported to Forrest.
Eric Barr, and he report to who? Sorry.
Yeah.
Andy, maybe it's better you can show your screen. You can show the picture.
Yeah. So what I'm saying, Andy, is if Eric Barr rejected it, then we need to push him and his boss. Yeah. They're the LMEA. The same way the Australian team's pushing a lot of stuff from America on the truck.
Okay.
CAD integration, Eric Barr, yeah?
Yes.
Who's Eric Barr work for? So he's PD, isn't he? He's not LMEA. Mark Rossi. Well, okay, manager, and then work for Dave Nowicki.
David, Novich.
So Eric Barr, body leader, not CAD.
Sorry.
Okay, so I want to see the emails. Can you copy me and Maggie? I want to see what emails you've sent on this topic to Eric. Okay.
Yeah, okay.
Then I want to see you elevate it to the next manager, but copy me on those emails.
Okay. Yeah. I just want to show you an example about cylinder bracket. Yeah. So I just because for FAA they want to use this one with CD391, but for us we need to follow C482. So and for LMEA they don't agree to use this. So that means if we want to follow C482, we need unique design of the fender.
Okay, but then we need a new machine if we can't be common, yeah?
Yeah, the fender should be common. If
No,
the
no.
bracket different, that
Sorry,
means the fender need a unique design.
sorry, Andy, if you use a different bracket, you need a new weld-fast machine, yes?
Yeah,
Is that correct or not correct?
we need unique drug welding machine. This bracket is very different.
Yeah. Okay. So we would, if we get common, we don't need new machine. But if we, is this weld fast technology or is this spot welded bracket?
The draw arc welding.
Arc welded. Okay.
Well,
Yeah.
When you say arc welded, is it drawn? It's drawn arc weld, is it?
Yes.
Okay. Okay. Not MIG weld, no?
No
Drawn
MIG
arc.
weld. Yeah,
Okay.
actually, for C519 is MIG weld. Yes, but for C82 is a drug welding. So we will follow the same design.
Okay. So we want the same bracket on
Yes.
both. Okay. So this is a high hertz. This is a good one. Okay. So hi Eric. Okay. Who have you copied on that note? No one. Can I see the addressees on that email? Scroll down, please.
Yeah, just example. Yeah, just the example.
This is Eric Barr. Yep. Okay.
Yeah.
Who's John Oliver?
He is the engineer working for Eric Barr.
Yeah, one question from Max for C482 program. Yeah, just get the Andy's words that 6483 will not follow the 6482 bracket. Is that right, Andy?
Yeah.
Yeah, but there is one kindly reminder that for the current CAF3 station in the respond line in ST330 station, which is the C482 and C489 John Arc auto weld station. I think CAF3 plant could not add another John Arc welding machine for unique bracket.
Yes,
So maybe the
this
option.
is what I mentioned. We don't have enough space.
Yeah. So
Okay.
if you cannot use the 482 bracket, you can choose the 489 bracket, I think.
Sorry, the 489.
490.
430.
Oh, 490. Yeah. Sorry.
490 or 430?
I think it's 490 because C482 and
Oh,
C490 have a different John Arc weld bracket. We have argued with PD for a long time, but finally they do not want to use it. So we add another weld bracket station, bracket machine for this station.
Okay.
Yeah.
So just recap for me. 490 has one level of bracket, correct?
Yeah, one level bracket.
430 will have another level of bracket, correct? And 482 will have another level of bracket. So there'd be 3 brackets. Would that be correct?
Yeah, yeah.
Yes.
Okay. And the facility would only have capacity for 1 or 2 or 3 brackets?
I think we only can contain 2, and if we have a third one, no space to add another tooling.
Okay. What's currently built in CAF3? What product?
Currently is C419 and C482.
Mm. Okay. So, Andy, I want you to, so on this email, you've only sent it to Eric Barr. I want you to, so let me see what he, can you scroll down the email to the last correspondence, please? Scroll down.
Sorry?
I just want to see the top of the email, please. I want to read the comments. Andy, for seats, what we need the DSL to stay common with the CD and CD 391.
Yeah.
Okay, but how long are they building the CD 391 for?
The CD 391, you just plug it.
Yeah, but what car is the 391? That's the Mondeo, is it?
Mondeo, yeah.
Okay, when does that stop?
You mean for FNA? For FNA, they will 1 year later. I saw the VPP.
Okay, so they have an overlap.
Yeah.
Reuse existing equipment. So they want to reuse. So then we need a Asia Pacific design, then, yeah.
Yeah.
Okay, this is a really good example, isn't it? We get product complexity.
Yes, and this is just for drug volume, and another one is for the fastener, for the closure handle, also another issue.
Okay, hang on a minute. Okay, so let's just talk this one first. So what I want you to do, Andy, on this email, I want you to write back to Eric and copy his boss. Okay?
Okay.
Copy Maggie and copy myself. Okay?
Okay.
Okay? And say, look, understand the North America concern, okay? But this product will be ongoing. This product, well, 430, okay, 391 will, well, we'll just say that we require commonality between models in our facility as well. So please, can you take this as LMEA, can you please request this of the PD team, okay? So we need to have this, okay? Just
you mean for unit design for AP?
Go back to Eric Barr, okay, and say, Eric, if he's LMEA, go back to him and say, no, Eric, understand your concern, but also as a customer, we require Commonwealth fast bracket with these models, okay?
Yeah.
Okay, can you please take this back to the program?
Okay, I will, yeah.
Okay, and then copy me on it, and if you want, copy Alan too, okay?
Okay, I will.
All right, what we need to, we may not win this, right? But what we need to do is start to, if we don't push it and we just accept their first response, then they will always take the easy path, okay?
Okay.
Okay, and nothing will happen. We will not make a difference, okay?
Yeah,
if we don't make a difference, we don't make a difference, we don't need an advanced engineering team, okay? So we must try and push this one, okay?
Okay.
Okay, what's the other one, Andy?
Yeah, I think this is the example for the fastener, and for the for the fastener, I didn't make a summary, but just check the data. When I finished, I will also send to you and LMEA. Okay. Okay.
We need to pull together something fairly quickly, I think, Andy, because with this change in plant, right, we should list all the impacts and put that into the feedback when we have our reviews, okay? What the impact of changing plants is. Okay?
Yeah, okay.
I'm thinking, if not this Friday, then next Wednesday we put up in a program review with Alan, okay?
Okay, yeah.
So you need to work quick on this.
Yeah, I will finish it tomorrow.
If you can finish tomorrow, which program review time frame suits you, Wednesday or Fridays?
So sorry, can you pardon?
If we put this in one of Alan's program reviews, meetings, which day suits you, the Wednesday meeting or the Friday meeting or none of those meetings?
I want to put in Friday because I have another topic for which it says to FWL PA cost study. So.
Okay.
Yeah.
Then put it in for aim for Friday, okay? Even if you not have finished, aim for Friday, okay?
Okay. Yeah, I will. Yeah.
Because remember, this complexity topic is very important.
So you want to involve Bar involved?
No, I want you to report out on the your assessment of the what our issue is now that we change plants.
Okay.
What's our issue with sealers, fasteners, weld-fast brackets? What are the things we've got to go and do? With Eric is a separate discussion. I want you to send an email again and say, look, this is still an open issue. We need this addressed. Okay?
Okay.
Okay? So it's not a case of we're not going to do it. We need to go and push getting a unique fender or something like that. I don't know what the answer is.
Yeah. Okay.
Okay?
Yeah.
So it's good that you're picking up these issues. I'm glad you're telling us about them now, but this is the time we've got to see what we can do to fix it. Okay?
Yeah.
And copy me on the correspondence.
Yeah. I will send it to you also.
Angel, sorry. I think I need a separate meeting to go through one by one to see next 4:30 for the printer change. Maybe today we have to finish now and want to book tomorrow.
Yeah, okay.
Yeah. So Andy, maybe we need your support because you're responsible for this project. So how about tomorrow, 8:40, 8:30, sorry, morning, China morning, 8:30. Is that okay for you, Andy?
Yeah, it's okay for me.
Okay. So I schedule a separate meeting. We need to go through one by one. And today we only discuss 3 topics. One is fastener, and so Paul will keep update, and we need a detailed report. And Angel, this one topic also we want to report to you, need your support. So Paul will give the material then send to you. And the other 2 we discussed. This one is Paul. Yeah, we also will prepare more detailed information and give the report to you, Angel. And yeah.
What's the hood one? You didn't share the hood one with me. What was the hood one?
Sorry, this one?
No, hood one. Line 21. Line
21.
For this one, we want to comment the C419 hood fastener with other program, but currently, based on the PD do some test, and currently we have the talk issue. And then let me share some document, and then you can have a look at the situation, and then this one is the summary. You can see here all the program. This boat is currently C419 boat, hood boat. The spec is this one, and all other C2 program, the boat is this one. And all other C2 program, the talk is common. We want to change this one, change the C419 boat to this one. And then PD do some test, and they recommended the new talk is this one, this number. It means if we want to comment the boat, the new talk for C419 will be this one. You can see this tolerance is very small. This tolerance is very small. Currently in CAF, the tooling cannot reach this tolerance. Now we ask some tooling supply. If we want to, we need to buy a new DC nut runner for control this tolerance. So the cost is here. This is the tooling cost. This is the tooling cost.
Okay, I don't understand what this 0.9 is. Why would they go to 0.9? 25 plus 0.9?
You mean which number? This one?
Yeah.
This one?
So if we go to the new bolt, why can't we go more than 0.9?
We do some test. We do some test for the boat, for the new boat, and in this turn, this number, in this turns, the boat can be in the good performance. So the new torque cannot over the 25.9.
What? Why?
Why? They do the test. You can let me show you the test.
I can't understand why the bolt can be 25.8 on other cars, but not on this one. What's the reason? What happens?
This is the test result. Let me show you. This is the test result from PD, and we buy some. You can see here. We buy some part, hood hinge fastener, and some body unit part for C419 MCA, and then the quantity is 14 number, and then we do the test, and then get the result. This number, the boat will be in the good performance.
Okay, so they're saying it can be plus or minus 3.4. Where does it say it can only be plus or minus 0.9?
This one is this number is for the boat itself.
Oh, 22. Okay, recommended. Okay,
yeah.
That's the recommended, right? I could recommend something could be 100. I could recommend maybe 90. Maybe not a strong recommendation, but I could still do 90, or I could do. I mean, what's recommend mean? Is it acceptable if it's at 25 plus or minus 3.4?
25, yeah, in this presentation you can see the 25. The 25 is a basic number for the C419. Basic number.
Go back to the sheet you just had, please.
This one?
Go back. Okay. So what constitutes a failure? Okay. So is PD saying you can only target 22.5 plus or minus 3.4? It's unacceptable outside that range. Why? Why do they say that?
You can see here. They have this.
Yeah.
This study. They have this study.
Yeah.
They have this study, and you can see this number. According to this number, I think. Let me check. I think this number. According to this number, I think.
I don't understand.
According this number, this number, and then some standard PD standard, they got this number.
Yeah. So, but what's it mean? It says it's recommended. Okay, I understand the recommendation, but what is acceptable? So, for example, for a margin on, say, a door to a fender, the recommended tolerance could be plus or minus 1 mil. Okay, but we may decide to go plus or minus half mil. Not recommended, but that may be still acceptable. Okay, so what's the logic of the words recommended? Are they saying that what happens if you go to 25? What happens if you go to the tolerance, the same as in other plants? What happens? Do you get loose torque? Do you get, I don't know. What's the consequence?
You mean for this other program?
Yeah, if you go to 25 plus or minus 3.8, what happens? What's the outcome? What's the failure mode on this C490?
The torque will be the boat will be not in the good performance.
But what's not good performance? Explain to me. Is it acceptable performance or is it not good performance? And what is the measure of performance?
Maybe I can prepare some document to show.
You understand what I'm saying?
Yeah, I understand. But this is based on.
It's like when CAE go and do a design of a car, okay? They will maybe design the panel with 1.2 millimeter thickness, okay? And they will pass the crash result. But sometimes the CA engineer will want to do better. You want to put more contingency into the design, okay? And then he'll change material to boron, or he'll make section bigger. But he already passed on the other section, yeah? All he worry about is his own performance being the absolute best, yeah? And he has no consideration for manufacturing or cost of car, okay? All he looks at is crash performance, okay? And he'll try and make it overachieve. My question here is the tolerance that we want to go to, is it meet the standard performance? Not whether it's recommended, but does it meet, in their test, will it meet their standard? Okay?
Mm-hmm.
I understand what they're recommending to go to, right? But the person recommending that he's not considering the complexity into manufacturing. He's just saying, I recommend this one, right? Because it's the most safest thing for him. I want to understand, do the other tolerances meet? And what I'm asking you is to understand what this test really means. If you understand what the test means, you'll be able to understand whether this assessment is fair. Okay, you'll be able to ask the next level of questions. But so does it fail if you go over 20? What is it? If you go over 25.9, what is the failure? What is the failure mode? If you go over 25.9, what happens? Does the bolt snap? Yeah.
The bolt will be in the how to say in English? Plastic deformation. The bolt will be in plastic deformation.
Okay. Well, I don't accept that because if you're using a common bolt, yeah. Oh, now I misunderstand. So you're saying still use a different bolt for C490?
Yeah, currently you can see here C490 is the only program that uses.
I thought you were looking. Sorry, I thought you were looking to change the bolt.
Yeah, we want to change this bolt to this one.
Okay. But they say if you change it, you need to use a different tolerance.
Yeah, this tolerance.
Okay, but I can't understand how the bolt can go into plastic deformation if the bolt is used on the other vehicles above. You understand what I'm saying?
Can I say again? What?
So let me annotate. Okay. So this bolt here, I'm allowed to do that bolt there up to 28.8 Newton meters. Yeah.
Yeah.
If I use the same bolt here, why can't I do it up to 28.8 Newton meters here? Why will it go into plastic deformation there for the same torque?
Same bolt, but different stack up. This test is I mean for different coating, different thickness, and then different material. The result will be different.
But I don't understand the torque though. Why will the bolt go into plastic deformation? if you're applying the same torque to the bolt.
This test is based on the C419 material and the C419 part. I'm not sure all the other programs do the similar test.
Well, that's my question. Do we have if we did the same test, maybe we've got a problem on all the other programs?
Maybe.
Have we looked at the test results from another program?
I'm not sure other programs do the similar do the same test or not.
Something doesn't sound right to me. Doing the hood up, it's generally a 2 mil reinforcement. You say the stack up's different. I wouldn't have thought it would be very different. You're talking hood hinge, yeah?
Mm-hmm.
I want you to, if you reckon that the stack up's different, show me the stack up for C483, C519, C346, C520, C490 and C482. You show me the stack up. Maybe the answer is I have to change the stack up. Something doesn't make sense to me here. Now, is this the bolt to the hood or the bolt to the body?
Bolt to the body.
Okay, maybe that's why it's different. Please show me the stack ups on all of them. I want to understand the difference. I want to see the test for C483 should have been tested too, yeah? Should have done the same test.
Yeah, should be.
So pull those ones out. I want to see the test results by the same group. Again, this will be, people will not want to change something, right? So they'll give you a result or make it hard for you, yeah? I still don't understand why this bolt would fail at that tolerance. It doesn't make sense. Is the speed of the machine too quick? Go back to the report.
That's fine.
Yeah, so is there a speed when they do this test? 100 RPM. Yeah.
That's all?
Go back to the page you just had. Okay, so it said here, stop there. Look, go down a bit. Go down.
往上有个100 RPM。
Okay, stop there, stop. It says speed stage, 100 RPM. Okay, is that what they tested the other ones saying? Who done the test? Someone in China?
Yes, in China.
EIC.
Okay. And did he do it on an actual body?
Only for the part, only hood hinge fastener and some body in one part.
In the library, not
Yeah, okay. So he done 20 tests, right? You say you're worried about the stack up. How realistic was the stack up that he done? And then I want to see the same test for the 483 and the 482.
This one is for C419 MC part, and
so he had a cowl top, and he had a reinforcement, and he had a hood hinge, yeah?
yes.
Okay, so I want you to do a bit more research. I want you to check the 483 design, the 482 design, and I want to see what the test result on them was. The same test result.
Yeah, I can compare what's the difference.
Sorry?
Well, I can compare what's the difference between the C419 MC and other program.
Yeah, something not right here. Something's not right. Something not makes sense to me. Okay, and you've got PD there in the REC, so you should be able to do a bit more research on this and find out what's not correct. Okay. Okay. You go away and do a bit more work on this one, please, if you can.
Yeah.
At worst, we'll learn a bit more about torque, yeah? We'll learn about their test. Okay. Okay. So the other question I have for you, if we go back to that table, the first table you had, the first slide, please.
This one.
Yeah. So in CAF3, do we have the talk linked to NGAVS or whatever it is? Is it recorded?
You mean?
Yes. So what I'm asking is, can you program the nut runner to apply a different torque for each car?
I didn't cut your point.
Okay. So when the car comes past this nut runner, can it change torque settings depending on what car it's doing? So will it know that it's welding a C490 and not a C482? Is there intelligence in that line that can do that?
Sorry, Andrew, you mean you want to data the actual data in CAF? How many of the torque for each model?
No. I'm asking you, if you had two different vehicles running down the line, one required 10 Newton meters and one required 20, does the PLC or the control system of the line, would it be able to tell the nut runner to do 10 or 20? Would it know what car it's doing up?
We use the torque wrench and window tooling for install the bolt, and then use the torque wrench for manual apply the torque. It's manual operator. No, it's manual one, not an automatic line.
So when you say manual, it's a clicker wrench or it's a DC nut runner?
Torque wrench. Not DC nut runner in body shop currently.
Okay. So how do they do it up first? They do it up by pneumatic nut runner, and then they do final torque with torque wrench?
Yeah, a special DC nut runner, too expensive.
So? Okay. What's the standard? Should we be using DC nut runner or not? What's their requirement?
For Ford, we require the DC nut runner, but in other CAF plant body shop, there is no program to use the DC nut runner. They use the window tooling and the torque wrench together with the torque wrench for control the torque.
They have a nut runner to do it up first attempt, and then they do.
The nut runner is only in the final assembly. In body shop, there is no DC nut runner.
Okay, but they don't do it all up with torque wrench, do they? They do partly with the pneumatic nut runner, then they do final torque with torque wrench? Or they do it all the way up with torque wrench from beginning to end? Find out what the process is.
In final assembly?
No, in body.
Can you again your question?
So in body, when they start doing the torque up, do they use a pneumatic tool first and then torque wrench? Or do they use torque wrench? They use pneumatic.
You use the window tooling first, and then use the torque wrench, apply the torque on the bolt.
Okay. Okay, so a torque wrench is not going at 100 revolutions per minute, correct?
Yeah, torque wrench cannot meet the turns here, the requirement of turns. This one cannot meet this one.
No, the torque wrench is not rotating at 100 revolutions per minute, correct?
Yes.
So all I'm saying is that the test that they did with in the lab was at 100 revolutions per minute. The method you're using with torque wrench is not 100 revolutions per minute. Did not match the real world. Okay. Driven on bolt, ultimate mode, all bolts, hang on. Just go back to that report. Go back. All bolts are fractured. The recommended torque cycle and maximum 0.43. So recommended torque. All bolts. Scroll down, please.
I can summary a presentation to show how they got this number. They have,
No, I can see that, but my question is, if you did the same test on all the other vehicle lines, we may have a problem too, okay? And their recommendation, okay, my question is, can you go above the recommendation? Yeah, is it still within their allowable range?
Yeah.
Okay. So where's the standard that says you cannot go above 80% of the yield torque? Yeah. So can you do a bit more research on this, please, and get back to me?
Okay, no problem.
Yeah. Because
no
I worry about the other vehicles. I think you have the same problem. I want you to understand how they did the test in the lab. I want to understand what tests they did on the other vehicles with that bolt. Okay?
Okay.
All right.
Okay, thank you.
All right, sorry guys. Sorry to ask so many questions.
No, thank you, Andrew, very much. You give our directions.
You'll get used to me. Sorry, I'm not angry, right? I just want to. I know these probably small, but I want to just explore a bit more. Okay.
Good. Yeah, this topic is very difficult for Paul. We communicate with PD engineers work level, so I think this meeting is very good for us. We need to further discuss with PD.
So part of this process, right? I won't get involved with your customers or your peers directly all the time, okay, on every issue. But what I want to do is get to a point where they start to listen to you, and they know if they don't listen or they don't do their job properly, then we're going to elevate the issue. We're not just going to let it go, okay? Yeah. So once they realise that we're going to push some of these topics, maybe they won't take the easy way every time, okay?
Yeah, sure.
All right. So it will take time and it'll be difficult, but we will need to do a lot of research to get our facts correct, okay? We may win some, may lose some, but we're going to push a little bit more, okay? So it'll be learning experience for me and a learning experience for you guys too. All right. Thank you.
Thank you, Andrew. Thank you.
Thanks, guys.
Thank you, Andrew.
Yeah.
Thanks.
Andy，所以我明天早上8点半，你嫌早还是晚？主要就你的时间。
没事，就8点半吧。如果你这边没，因为他们可能9点要开始那个 program meeting 吧，应该明天的那个。对，
是的，所以我想8点半。
快点过的，反正就那个，我明天做个300出来，跟安全他们讲一下就可以。我看如果是不是安全要我在那个明天的会上谈那个事情，我想要礼拜5的吧。